to look at solving inequalities. Now, when you're asked to solve an inequality, what you're going to be doing is you're going to be getting an answer. So you need to get your answer in the form x greater than, or x less than, or x greater than or equal to, or x less than or equal to something. And you'll usually be asked, you're usually told that x is an element of either the natural numbers, the integers, or the real numbers, and you'll be asked to plot your solution on the number line. So we've learned how to do that. Once we have x in this form, we've learned how to plot one of those inequalities on the number line depending on the type of number that we're given. Okay, so when we're asked to solve an inequality, and we'll be doing a few examples of it in a minute, it's really, really straightforward. It is exactly the same. So exactly the same as solving equations. So basically you treat the inequality symbol, and what do I mean by that? I mean the greater than, less than, greater than or equal to, greater than, less than or equal to. So you treat the inequality symbol as if it was equals. As if it was an equal sign, except, okay, and this is really important because there is an exception, because it's not exactly the same as an equals. And this is really, really important, except for when you do one of two things. So except if you multiply or divide by a minus number. So if you multiply or divide by a positive number, nothing changes. If you add or subtract both sides, nothing changes. If you square both sides even, nothing changes. But if you multiply or divide both sides by a minus number, then you must change the inequality symbol around. I wrote the twice. You must change the inequality symbol around. So what does this mean? Basically, if you had a greater than, it would turn around, and I indicate it like this, it would turn around and become less than. It would change into less than. And if I'd started with less than, it would turn around, and this is how I indicate it, with a little arrow telling me to turn it around, and it would change into greater than. Let's take a look at what that looks like. So I'm going to talk about why afterwards. So first we're just going to learn how to do it, and then we'll talk about why. So example 1, solve x plus 2 less than 2x minus 6. X, well, we need to know what type of number it is. X, an element of the integers, and plot your solution on the number line. Okay, so if this was an equation, it would look like x plus 2 equal to 2x minus 6. That's what it would look like if it was an equation, but it's not an equation. But if it was an equation, we would do letters left, numbers right, and when you change sides, you change signs. So let's take a look at that. I start with my inequality as it's given, x plus 2 less than 2x minus 6. And I'm going to move the x's to this side and the constants to this side. So I get x minus 2x less than, this becomes a minus 2 minus 6. So I've changed sides, which means I've changed signs for these guys here, but I didn't change my inequality symbol around. Why? I didn't change my inequality symbol around because I didn't multiply or divide by a negative number. So everything stays the same. I'm going to simplify. X take 2x gives me negative x. I didn't multiply or divide by a minus sign, so that stays as it is. Minus 2 take 6 is minus 8. Okay, now that's great, but that's not in this format. I need x, not a negative x. So what do I do? Well, the coefficient of x here, apologies, my smoke alarm's going off. Sorry. So the coefficient of x here is minus 1, so I am going to divide both sides by minus 1, or change the signs of everything, we sometimes say. Now, I am dividing by a negative number, which means that I change the sign of everything, including the inequality symbol itself. So this is going to change around. So now I'm going to write down my answer. This will become a plus x, this will become a greater than sign, and this will become a plus 8. So x is greater than 8. Okay, and now I must plot my solution on the number line. They're integers, so whole numbers. And I'm looking for numbers bigger than 8. So if I have 6, 7, 8, 9, 10, I didn't need this many numbers, 11, 12, 13, 14. I could have had half the number of numbers here. I didn't need all of these. And they should be dots. Okay, can I ever be equal to 8? There's no line underneath here, so I can't be equal to 8, which means the first number bigger than 8 is 9. And I do dots going in this direction. And it's handy once I've set up my solution like this, and I colour in the arrow as well to indicate that I'm going on forever in that direction. Okay, so that's how we do it. That's how we solve an inequality that isn't just a basic x less than or x greater than, and we can treat it just like an equal sign. But if we multiply or divide by a minus number, we have to change the inequality symbol around. Right, I want to do one more for today. And what I'm going to ask you to do, because I'm not going to assign homework tonight, so what I want you to do is, once I've written down this example, I want you to try it yourselves. I want you to pause the video, try it yourselves in your homework copy, and then come back and see the solutions. So we're going to solve the inequality (2x plus 18 less than or equal to, I could have done a greater than sign. No, we'll leave it like this. Less than or equal to 4x minus 2. And x is a real number. So plot your solution on the number line. Okay, so once you have that taken down, pause the video, try it yourself in your homework copy or on a piece of paper or on a whiteboard, and then come back and check if you have it right, and then take it down into your notes copy. Okay, how did you get on? I'll check in with you guys on Thursday and find out if you did that correctly. So again, letters left, numbers right. 2x, the 4x comes over and becomes minus. I didn't multiply or divide, so my inequality symbol stays the way it is. The 18 goes over and becomes minus. I didn't multiply or divide. and my negative 2. Then I simplify. 2 take 4 is minus 2. Minus 2x less than or equal to. Minus 18 take 2 gives me minus 10. Now, if this was an equals, we would divide across by minus 2. So that's what we're going to do now. We're dividing by a minus 2, which means my inequality symbol is going to turn around. Minus 2 divided by minus 2 is 1, and I get x, which is what I wanted. This becomes a greater than or equal to sign. Minus 10 divided by minus 2. Sorry guys, this was 20. I did the division in my head accidentally. Sorry about that. Minus 18 take 2 is minus 20. Minus 20 divided by 2 is a plus 10. So my answer is the set of all numbers that are greater than or equal to 10. And I still need to plot my solution set on the number line. They're real numbers, so I'm going to be colouring in the line. And I'm looking for numbers bigger than 10. So bigger than or equal to 10. So we might have 8, 9, 10, 11, 12, 13. And my solution set, can I be equal to 10? I can. So I do a little coloured in dot there. And I'm going this way. The arrow, the inequality tells me which way to go. Numbers bigger than 10. I'm colouring in the line. And I colour in the arrow as well to indicate that I keep on going forever in that direction. So that's the second example. We're going to stop there for today, and tomorrow I'll do some more examples with this, and I'll ask you to practice as we're doing the notes again, and I'll also talk about why we change the inequality symbol around and why we only do it at this point. Okay, thank you.